2019 higher level question 5, transformation geometry. So this is our question. The figure shows the logo for a lighting company. The logo is subject to transformations in the following order. So an axial symmetry from P to P1, central symmetry from P1 to P2, translation from P2 to P3, rotation anti-clockwise through 90 degrees from P3 to P4. So we're given the setup of the question, all the measurements that we need. Part A then is to draw the given figure, and part B is to determine and draw the image of the logo under each of the above transformations. So far what I've set up is I've located each of the four, the P's, P1, 2, 3 and 4, and I've set up most of the shape up here. The one bit that I haven't done yet is locating the bits here on the side. So for that we need their tangents. So what we're doing is it's a tangent to a circle. This is our circle. This is the point outside the circle that the tangent is drawn from. So you're going to join this point to the center of the circle and bisect. It happens to be 50 millimeters and the radius of the circle, so this point here is 25, the radius of the circle is 25, so that's halfway along it. So all we're doing is putting the point of our compass on that point and swinging an arc so that it cuts through the circumference, and they are our points of contact. So we still do need to draw these correctly. So it joins that point down the center, points of contact to here, and same on the opposite side. So they are our circles, our tangents, and we're just going to darken in our outline of this here. And that gives us the shape, so that just sets that up for us. The other stuff that we need to get going with this one, just so we can do the rest of it, we're just going to label a couple of the other points. So we have P here, I'm going to go with probably A and B, C and D here. Then we just need maybe this point here, E and F, and then the center up here, G. That should be enough points for everything that we need. It's plenty as it is. So that'll give us enough information. So the first one is now we're going to start doing our translations. Transformations. So the first one is from P to P1 is an axial symmetry. So P1 is not a point on the axis, it is the end point of where point P is. So you're going to have to join the 2 points together, and we need to find our axis, so you're going to bisect the distance between the two. So bisect this line, extend over halfway, swing an arc, same on the other side. And this line here, the bisector, is our axis line. So each point is going to move perpendicular to this axis and equal distance on either side of the axis. So taking each point in turn, we already have P, so let's take the rest of them now. So you can take them all individually or maybe one or two at a time. So I'm going to take two at a time. So point A and point B. They're going to be equal distance, whatever's the distance there from the axis on one side is the same distance on the other side. So from the axis to A, same distance on the opposite side. From the axis to B, same distance on the other side. So this is B1 and A1. Now we can join them up. Some of our other points now that we're taking, so we can take, we'll finish off the square at the base, or the rectangle at the base. Point D and point C. So again, same principle, so from measuring from the axis to the point, same distance on the opposite side, that's point D1. And this is C1. Again, so P joins to D over here, P joins to D, so P1 is going to join to D1. B joins to C on the original, so on the image, P1 is going to join to C1. And that gives us the rectangular part. Next part is going to be finding the circle, so we'll draw the center of the circle now next. Taking point G And I'm going to take F and E as well. So same distance on either side, so measuring the distance from the axis to point G, check it, and onto the other side as well. That's G1. And drawing our circle up here again. And this point up over here where that line cuts through the circle, that's going to be F1, and where this line cuts through the circle is going to be E1. So we can join these back down to E joins to A, so E1 is going to join to A1. And same for F, that also joins to A, so that gives us this, and then just finally just darken in the rest of the circle. And that completes the first part of that, which is our axial symmetry. The next part is going from P1 to P2, and this is a central symmetry. So we've located those points already. So again, P2 is not the center of symmetry, it is where point P needs to end up. So again, we're going to join the 2 points together and bisect that line that forms. And where this time where that bisector passes through the line joining P1 to P2, that point here is our center of symmetry. So that's the point that we're looking for. And again, this follows along much the same idea, except this time each point is going to pass through the center of symmetry, and it'll be the same distance on either side. So point D1 here passes through the center of symmetry, and we're going to take the same distance out the opposite side. So from center to D, and same distance on the other side. This point here is D2, doing the same thing for all of the other points, so taking point A, make sure it goes through the center, and B, that can go through the center as well, center symmetry. So measuring from A, gives us A2, and measuring to B1, this is B2. So again, line join these up. So you got B2 and A2, doing the same thing now for, so P joined to D, so they're going to keep joining together. C, the same, C goes through the center symmetry out the other side. Distance from the center symmetry to point C. Okay, so again, taking the final points, point G, through the center, out the other side, measuring the distance from the center to G. That's G2. Drawing our circle. So point E1 again, so it's the same principle the whole time. This is going to be E2. Our F1 passes through the circle, that's going to be F2. Up on the side up here. So again, these join down to point A. And then we darken in the rest of the circle. So the third transformation, going from P2 to P3, is going to be a translation. So P2 is here, this is P3. We're going to again join P2 to P3, just like we did for all the previous ones. This time all lines are going to move the same distance and same direction, as all points will. So going parallel to that, taking point A and B, same distance as well, so we've already gone the same direction. Now we're going to go same distance, so setting the compass to the distance from P2 to P3, going to mark that from A2, that's going to give me A3. Same thing from B2, that's going to give me B3. So continuing on with this for the remaining points, for point D and E, and then we can take point G as well. I'll come back to the other ones. So again, same distance, this is G3. C and C3 and D3, so I'm going to join all those points up first to form the box. Check that one. So center of our circle again, which we already have, same size circle, radius 25 all the time. Then we just need to locate two more points, points E and F. So that's going to be point E and point F. So again, these are going to join back down to A. Giving us the two tangents, and then just darkening the top part of the circle. Alright, so final part of this then is the final transformation is rotation anti-clockwise through 90 degrees from P3 to P4. So we've got point P3 up here. P4 is this point, and we need to get them to go anti-clockwise, so 90 degrees anti-clockwise. So best way to do this is first join P3 to P4, and then put your finger down on one side of the line. So if I put my finger down here, and it's going to swing, so if it's going to swing up this way. So from P3 to P4, is this clockwise or anti-clockwise? This way it will be going clockwise, so it's not, the center isn't down here. If I put my finger up here, and again swing going this way, from P3 to P4, is that clockwise or anti-clockwise? That's anti-clockwise, so our center is going to be up on this side here somewhere. So normally what we'd have to do is so we're after creating a line along here, and the center, so if this is P3 up here is P4, our center would be up here somewhere. So we join the 3 points together, so it's, when they're all joined together, it would form a triangle. This angle up here needs to be 90 degrees, so 180 angles in a triangle minus 90 is going to leave us with 90. So the remaining two angles, this one and this one, are both will add up to 90. It has to be an isosceles triangle because the distance from the center has to be the same from center to P3 as the center to P4, because they're parts of an arc. So dividing that by 2, we get 45. So the angle that we need here is 45 degrees. So you would then get your protractor and measure an angle along here up to 45 degrees. So up along that way, same coming along this way. But as it happens for this question, this angle here is already 45 degrees from this one, and same for this, they're both 45 degrees. So we've got 45 here as well. So where though they intersect is this point up here. This is the center of rotation that I'm looking for. So what we're doing is we'll join every point now to the center. So joining point A3 to the center. It's going to form an angle of 90 degrees, so using your protractor or sliding set squares, whatever you want to do, I'm going to mark an angle of 90 degrees. Draw a line from the center of rotation out through that point, and then we're going to swing that distance. So it's the distance from the center of rotation to the point, so point A3. We swing this around until it intersects the other line we've just drawn. This is point A4. Going to do the same thing for each of the remaining points. So joining this point to B3, same idea. So again, with your protractor or sliding set squares, whatever works for you, marking 90 degrees out here, taking the line from the center rotation out along that mark, measure the distance from center rotation to point 3, swings this around, and this point up here is B4. Join up the points, and that gives us that first line. Then the same thing now for the remaining points. So from center of rotation to point C, measure our angle around that one, 90 degrees again. So all of them are moving at the exact same angle. C4. So all our points are treated the same way. Now just one thing on this, accuracy is hugely important inside in this question. If you make an error in the first one, it's going to transfer through for the remainder. So being accurate from the start is very important, and I'd suggest you keep your pencil extra sharp for these questions. So you might need to be topping it a couple of times for this question. It's just a way of ensuring that your lines stay narrow, because a thick line is going to make things less accurate. So we're almost there with the center rotation again joining to points G, and we'll do the same thing for E and F. Measure the distance out to G, rotate that around. Now I forgot to measure my line. So line G, 90 degrees. So up here is point G4. Can draw in that circle again. Now, instead of taking the angles for this last one, all I'm going to do is I'm just going to take the distances. So this point here is point E. That's on the left side of this, so that's going to be up here. Point F is this side, that's going to be down here. So we can just join them back down to A. And finally just darken in the circles around the outside. And then that will finish off this question for us. So this is the 2019 higher level question 5.